All right, next up, the power reducing identities that you see here. So we've got sine squared u is equal to 1 minus cosine of 2u divided by 2. I'll show you why that is. In order to show you why that is, I'm going to refer back to a double angle identity for cosine. So if I have the cosine of 2 times theta, that was equal to 1 minus 2 times sine squared theta. Then, if I were to rearrange this a little bit, if I add 2 sine squared theta to both sides, I'd have 2 sine squared theta here. And that would be equal to 1 minus, I'm going to subtract cosine 2 theta, so 1 minus the cosine of 2 theta. And then I would divide by 2 on both sides. So those 2's cancel, divide this by 2. And ta-da, sine squared theta is equal to 1 minus the cosine of 2 theta all over 2. Okay? And you could do the exact same thing with the other one. So if I do the sine or cosine squared, let's say I wanted to work with that one. If I remember that cosine of 2 theta, so using again the double angle identity for cosine, that's also equal to 2 times the cosine squared of theta minus 1. And if I were to work that out, I would probably add 1 to both sides. I'm going to write it backwards just for the sake of having it look the way that it does in the answer. 2 cosine squared theta would equal the cosine of 2 theta plus 1, or 1 plus that, either way, commutative property, we can do that. Divide that by 2, and we'd be able to say, hey, cosine squared is equal to 1 plus cosine of twice theta divided by 2, which is what you would see right here. Okay, and then finally tangent. There's a lot extra for this one. So if I'm working with tangent, in this case, I know that tangent squared of theta is equal to sine squared over cosine squared. So I got sine squared theta over cosine squared theta. And then I'm just going to use the 2 previous identities. Sine squared is equal to this thing. So I got sine squared, I got 1 minus cosine 2 theta over 2. Minus cosine 2 theta, there we go, over 2. And cosine squared is equal to this guy, which is 1 plus cosine squared, or 1 plus, not squared, cosine of 2 theta over 2. And then I got a complex fraction here. So fraction divided by fraction, I should multiply by reciprocal. Now, when you do that, the 2's will cancel. Okay? And hopefully that's an obvious type step that we talked about today in class. So this is going to end up turning into this thing over here. It's going to be 1 minus cosine 2 theta over 1 plus cosine 2 theta. Like so, which is what you see in the identity box over here for tangent squared. So that would be the 3 power reducing identities, one for sine squared, one for cosine squared, one for tangent squared. Hopefully it makes sense.